Right, good morning. Let's start our session. So in the previous class, we were discussing about, we started the practicals of Kubernetes. So let me start from there, from where we have started in the previous. So we have seen how to create a pod by using YAML file, right? So first of all, what are the objects we are going to see? By using Kubernetes, we can create various types of objects. By using Kubernetes, we can create various types of objects, okay? What are the various types of objects that we can create? We can create various types of objects, like we can create pod, we can create service object, namespace, secrets, okay? There are different objects, replica set or replication controller, deployment object, like that we have different objects. The very first object we have created in Kubernetes is pod. How can we create an object in the Kubernetes? Suppose if I want to create a pod in the Kubernetes, what are the different methods I'm having? Either by using a command, there is a command called kubectl create, or otherwise there is a command called kubectl run. See how to create a pod. We can simply run this command kubectl run image name and name of the pod. So by using the simple command also we can create a pod, but actually this is not a good practice. We have to write an YAML file and we have to deploy we have to create pods by using YAML file. So for that purpose we have understood YAML file. So what is a pod? Pod is a very basic thing. The smallest object in the Kubernetes is pod. The next thing is we have some drawbacks in the pod. You know, we have seen the YAML file of the pod, okay? And we have seen some drawbacks in the pod. That's why to avoid the drawbacks in the pod, we are going with an object called replication controller. We are going with an object called replication controller. What do you mean by replication controller? Let's understand. So replication controller is mainly for managing multiple replicas. If we want to create multiple pods of same object, then we can go for replication controller. We have also seen the YAML file of replication controller. This is the YAML file of replication controller. So I want to create a replication. If I want to create a replication controller, I will give the kind of the object. I will mention the kind of the object as replication controller. And this is a metadata session to provide the details of author and all. So and this is the specification section of replicas. How many replicas we would like to create? 3 replicas I would like to create, and name of the pod and all, name of each and every pod. See, the name of the pod is HTTP pod. Name of the replication controller is HTTP RC. See, this metadata belongs to replication controller, and this metadata belongs to particular replicas. We are creating 3 replicas, and each and every pod, name of the each and every pod is HTTPD pod. And the image we are using is HTTPD. This image we are pulling from Docker. This is the specification section which gives us the Docker details, Docker image, Docker container. Okay. So the name of the Docker image is HTTPD. We are pulling it from Docker and we are going to create a pod. Kubernetes uses Docker images only. So Kubernetes does not have separate images to create pods and all. So previously we have understood the concept of Docker. We know how to pull the Docker images and we know how to create Docker containers. With the help of Docker image, we can create container. If I run the Docker image, that will become a container. So same concept here also. Kubernetes will make use of Docker images and it will create pods. And I already told you there is no difference between concept of pod and container. In the Docker, it is running as we are calling it as container. In Kubernetes, we are calling it as pod. Concept wise, it is same. Okay. But with the terminology we are using here is pod, and I already told you inside a pod we can run many number of containers. If I run only one container in a pod, both are same. Pod and container both are same. But the only advantage with the pod is inside pod we can run any number of containers. The advantage of pod is inside pod we can run any number of containers. That is the one thing we need to understand. So we also understood that this YAML file. Let me see whether the cluster is created or not. Just now I have created a cluster. So cluster is created. How to connect with the cluster, we know, right? We need to select that particular one. Go here. We have an option here. Click on connect. and you will be able to see one command called this particular one. Okay, so copy that command and run in Cloud Shell. Okay, once this particular terminal is open, so we can interact with the Kubernetes. Okay, we can interact with the Kubernetes. You see, we don't need to give the command. The command is automatically getting copied to here. So it is asking whether you want, it is asking some permissions as I'm authorizing. So that, yes, once it is authorized, then we can able to connect with the cluster. I'm able to connect with the cluster now. You can just give ls command to see the list of files. These are the files I have. These are the files we have seen yesterday. These were the files we have created. And if you want to see the pods that are running, if you want to see the pods that are running, what is the command we have used to see the pods that are running here? The command kubectl command to see the pods running. Kubectl get pods. If I give kubectl get pods, you can able to see that no resources, we don't have any resources found in the, it is showing that no resources found in the default namespace. We don't have any resources here now. Okay, if I use a command called kubectl get pods, we don't have any resources found in the default namespace. Why? Because we have an YAML file, but we need to run the YAML file. We need to run the YAML file so that we will get, if I run the YAML file, then I will get commands. Okay. So how to run an YAML file? Can you tell me how to run this YAML file? I have an YAML file. How to run the YAML file? If you want to see the contents of the YAML file, what command we can use? Pod definition 1.yaml. So this is the YAML file that I'm having. Okay, if you want to clear the screen, here also you can use a clear command. For now, I'm going, yeah. You can use clear command here also for clearing the screen. And you can use a command called kubectl create -f. See, from the YAML file, how to run an YAML file. We have given the contents in the YAML file. How to run an YAML file? Kubectl create -f YAML file name pod definition.yaml. So this is how we will give the command so that it will show the pod is created. And it will show like pod is created and all. If you want to see the list of pods and all, you can use kubectl get pods. So one pod is running now. Nginx pod is running. This is the pod that is running. And we have also one more YAML file. We can also run that one by using kubectl create -f. The name of the pod is the name of the YAML file is replication controller. Replication controller.yaml. So I'm using replication controller.yaml. It is also showing replication controller is created. You can use by using a command called, you can see by using a command called kubectl get pods. Now you see one Nginx pod was running. This is for, we have created this for YAML file. Okay. This is a pod actually. This is the pod. And everything is a pod. But this pod was created 41 seconds ago while we have run that the pod definition.yaml. And the remaining 3 pods were created now after running this replication controller.yaml. And we have seen this procedure. What is the difference between pod and replication controller? If it is a pod.yaml, we cannot create more than one pod. Only you can able to create only one pod with the help of this one. With the help of this one, you can able to create only one pod. What about the next remaining things? If I go with the replication controller, you can create any number of replicas. You can create any number of replicas, and you need to specify in the YAML file. You need to specify. Here I have mentioned 3 replicas. If I give 5 here, even 5 replicas will be created. If I give 10 there, 10 replicas will also be created. Okay, this is about replication controller. So I am going to delete all these things. I am going further with the replica set. So you understood the difference between pod and replication controller. 2 objects. You understood the difference between 2 objects. That's why now I am going with another object called replica set. So first, let me delete all these things. How can I delete? How can I delete all these things? We have a command kubectl delete -- all pods. We can delete all the pods. Even though if I delete all the pods will not be deleted, right? You see, I'm using this command, pod is getting deleted. But when I'm giving kubectl get pods, okay, only one pod got deleted, remaining 3 pods are running. So the pod we have created by using pod definition.yaml that got deleted. That one got deleted. Okay, that one got deleted. But the replica set is not getting, this replication controller was not getting deleted. So if I want to delete this, what I have to do? I have
You need to delete the YAML file.
We have to delete this YAML file. So how to delete an YAML file? We have a command for that. So you can delete kubectl. What is the command we have used for deleting an YAML file? Kubectl delete -f. To delete the replicas, we can delete the YAML file. So replication controller got deleted. Okay. So now you can see by using kubectl get commands, we don't have any files. ls command. I'm going to see, even I have deleted this things here. Okay. So the file will be there. File will be there, but until we run this, okay, until we run this, they will not be created. So if you want to delete these files also, you can delete by using rm space pod definition.yaml. rm space file removing. For removing the file, we can use a command called rm space replication controller.yaml. The file name we are using. Now you can see only one file is there, that is called some readme file. No worries about this file. We don't have any YAML files now. Now we will understand a replica set. What is this replica set? Pod is the smallest object we have created, that we understood. The next level is called replication controller. Okay. Now we are going to understand what is replica set. Replica set is similar to replication controller only. But the only additional thing we can see here is, in the replica set, we have an additional field in the specification section called selector field. If you go to the YAML file of replication controller, this is the YAML file of replication controller. Here you have two specification sections. One specification section, last specification section is for Docker container and Docker image. Okay, you don't need to worry about, you have to remember like this. The last specification section is for Docker image and Docker container, Docker port numbers and all. And the previous, the first specification section is for replicas. And the replica specification section, you see, we have replicas as 3, and metadata. We have provided some metadata by using a template field. Okay, apart from that, we don't have anything. If you go to replica set, this is replication controller. Okay, this is replication controller. You see, there is a difference between replication controller and replica set. If you go to the replica set, so the same YAML file we will take, but one more field is added here. Under specification section, under first specification section, one more field was added, that is called selector. Selector, under selector field, we have one more component called match labels. Under selectors, we have match labels. Under match labels, we have a type called web server. These three things are very important. Selector field we are adding. Except this replication controller and replica set, both are same. So the only difference between replica set and replication controller is, in replica set, we will be having a selector field. By using the selector field, we are having a concept. We will understand that. So what is the selector we are using? So the selector field we are using, under selector we are using match labels. Under match labels, we are using a type called web server. We are using a type called web server. Okay. So now, so before, you see here, before, pod is the smallest Kubernetes object, we understood. Next level is the replication controller. The difference between pod and replication controller is that with the help of pod YAML, we can create a single pod. With the help of replication controller, we can create multiple replicas. And there is a difference between replication controller and replica set. The difference is like, in replica set, we will be having a selector field, okay, with match labels. In replica set, we will be having a selector field with match labels. In replica set, we have an additional field in the specification section called as, we have an additional field in the specification section called as selector field. And the selector uses a child element called match labels. Okay. So based on this, we will search for a pods based on a specific label name and adds them to the cluster. So what we are going to do, suppose if I give the replicas as 4, what happens? How many replicas should be created if I give the replicas as 4? 4 replicas should be created, right? 4 replicas should get created.
Yes.
So now, what is the image I'm using? You see, what is the image I'm using? Tomcat image. You go to the last specification section. We are using an image called Tomcat image. And what is the name of the container? My web server. Okay. What is the pod name? What is the pod name we are giving? Can you understand what is the pod name? Here we are specifying the name of the pod as name of the each and every pod as Tomcat-pod. So this is the image name, this is the container name, and this is the pod name. This is the pod name. And the next level is what? Next level to the pod is what? Replica set here. What is the replica set name we are providing? Tomcat-RS. Tomcat-RS is the Tomcat-RS is the replica set name. Tomcat-RS is the replica set name. That's fine. Now, if I give the replicas 4 replicas must be created. But what happens here? There is a small thing we need to understand. We need to understand that whenever if some other web server, if some other pod is running, with a match label called web server, let me create one pod with a name called web server. Even we can create pod by using command, right? We can also create a command by using pod. Okay. Let me create a pod with the name called web server and by using the same image called Tomcat. Okay. So how can we create? Let me show you. kubectl. I'm using a command called kubectl. Create. Sorry, not kubectl create. What is the command we use for creating a pod? kubectl run hyphen image. Hyphen image. What is the image name I'm using?
Tomcat.
To image the I'm going to use the image called Tomcat, and I'm going to use the pod name as
Web server.
web server. So this is the name of the pod. This is the pod I have created, web server pod I have created. Okay. So now you can use a command called kubectl get pods. You can use a command called kubectl get pods for looking at the list of pods and all. We have only one pod running here. Now I am going to give the name of this one VIM space replica set .aml. I am going to copy this. I am going to give this AML file here. So insert button. You can paste the entire AML file. This is the entire AML file. I am copying the entire AML file. Copying it. I am pasting it by using Control V. Escape button. Shift:WQ. So after pasting the contents of that AML file, now we need to run this AML file, right? You know the command, how to run the AML file and all. kubectl create -f. What is the name of the AML file? Replica set.aml. So I have given the contents of replica set. I need to run that AML file so that the replicas will be created. So now actually replica set is also created. Okay, replica set is also created. Actually, we'll see the list of pods now. We'll see the cubes by using kubectl get pods. We will see the option called get pods. So what happens is actually we asked for creating. Let me go for kubectl get pods once again. It will take time. Please wait. So the concept is that under replica set, the main concept is that suppose if already a pod called web server is running, if a pod is already running, okay, and if you are going to create a replica set of the same type, what we are doing in the AML file, you see, What is the how many replicas we are going to create? 4 replicas we are going to create. And if already a pod called web server is already running, then only 3 replicas will be created. That is the idea of replica set. So if outside, if any similar type of pod is running, it will consider that it will identify by using a selector called match labels, and the type of the pod is web server. The type of the pod is web server. Then only 3 replicas will be created. Along with this one, we totally will be having 4. Totally, we will be having 4. That is the idea of this one actually. So still some replicas are being created. So you can go to the, maybe this, maybe there are some issues with this. We have taken small size, right? Some pods are not even creating. They are still showing as pending set.
Vamsi, but we can see 5
Yeah,
pods right here.
what I'm saying. They are not updating. Actually, according to the concept of replica set, okay, you understood the concept, right? We have already created a pod with a name called web server, right? We have already
Yes.
created a pod called web server. Again, I am going to create a replica set. And in my replica set also, what I am creating, I am going to create some pods related to web server. So if the label is matched, what happens? It should create only 3.
1.
It should create only 3. It will also consider this particular one called web server. Totally, we have to see only 4 things. Understood, right? Totally, we have to see only 4 things. But see here, still some pods are not, and because of the memory, because of some memory issues, we are not able to see the exact output. Usually, we have to see 4 only. 3 Tomcat RS, 3 replicas. This one, 3 Tomcat RS, and 1 web server. Only 4 things we have to see. Okay, that is the basic idea of replica set. Even if you want to practice, you can go to the Kubernetes documentation. That is replica set ML. Go to the replica set ML. How many replicas we are giving? So 3 replicas. If I'm going to create 3 replicas, so there will be a field called selector, match labels, tire is front end. Okay, tire is front end. You see the concept of replica set. It will ensure that the number of pod replicas are running at any given time. The specified number of pod replicas are running at any given time. That means, so if you want 3 replicas, and if with the same name, if any other replica is running outside, if the same name, if any other replica is running outside, then it will create only 2 replicas along with this one, which is present in the outside. Totally, we should get 3. Okay, it will also consider the pod which is running outside. It will also consider the pod which is running outside if the label is matched. If the label is matched, how many labels? See, what is the thing we are providing here? What is the difference between replication controller and the replica set? In the replica set, we are going to provide a selector field. Under selector field, we are giving match labels. Under match labels, we are giving the name of the pod and all. So we are going to create a pod with this particular name. If the same pod is running outside, it will create only 2 replicas instead of 3. That is the basic idea of this one. So maybe it is not, this one is not getting updated. Let me check one second. Let me try once again. Clear screen. Okay. So ls command, I'm removing this one, rm space replica set .yaml. So we don't have this file. And let me try kubectl get pods. We don't, okay, we have deleted this one. Anyhow, pods are running. We need to delete these pods also. How to delete all the pods? Kubectl delete -- all pods. Kubectl delete -- all pods. We have a command called kubectl delete -- all pods. If execute this command, all the pods will be deleted. Now we can see no pods are running. Okay, we don't have any. What happened? We have deleted, right? Okay, still it is running. You have deleted the replica set.yaml. YAML file is not there, but why it is showing the pods? Okay, let me check why. See, actually, whenever we delete the YAML file, so whenever we delete the YAML file, it should also get deleted.
All the
So,
container.
sorry.
Yeah. Whenever we delete that YAML file, all the pods gets deleted, right?
All the pods should get deleted. So, but anyhow, they are not getting deleted. They're automatically getting created again. So usually the concept is like that. Whenever we delete the YAML file, no pod should be there. Okay, no pod should be there. All the pods must get deleted. Even I have tried deleting all the pods. They are getting they are maybe the YAML file is also not showing there. Okay, YAML file is also not showing there. Maybe it is not getting updated. Okay, maybe the cluster is not getting updated. That is the problem. That is the issue. That is why we are not able to see the exact output. Okay. So anyhow, these pods are still running. Okay. Cluster is not getting updated or not. I'm not sure. Okay, first we will see. We'll go with the remaining one. I'll see that. Okay, I'll check once and I will get back to you. So anyhow, we understood the concept of replica set, right? In the replica set, what you have to understand is if you want to create 4 replicas, if you want to create 4 Tomcat replicas, you can give the replicas number as 4. But under replica set, we are using a field called selector. Under selector, we are specifying the match labels. So if any pod is running with a label called web server, so it will create only 3 replicas. Why? Because it will also count this pod also. By counting this pod, okay, by considering this pod, by taking this pod into consideration, it will create only 3. That means totally 4 will be there along with the pod that is running outside. Suppose if 2 pods are running outside with the same label, if 2 pods are running outside with the same label, what happens? According to replica set, only 2 will be created by considering the pods that are running outside. So this is the actual concept. Okay, we'll see now. I'll get back to you. I'll explain you why the cluster is not getting updated. I have to check once. So then next level is like what is the next level of the pod? The smallest thing is the smallest level is pod. Next to the pod, we discussed about replication controller, and there is a drawback in the replication. See, actually, both replication controller and replica set is same, but only except that the selector match label concept. Okay, we are adding that selector match label concept. So apart from that, both are same. Both are used for creating replicas only. So we are managing the replicas, or we are creating replicas only for the purpose of load balancing. Why we are creating replicas? We are creating replicas only for the load balancing and auto scaling. Okay, we are using for this one. Maybe I'll check what is happening with the replica set, why it is not getting updated, and I'll tell you. So next level is deployment. Next level is deployment object. What is the use of this deployment object? So this is used for performing all the activities. It is used for performing all the activities that a replica set can do. Okay, it is used for performing all the activities that a replica set can do. But only advantage here is we can go for handling rolling updates here. Let me show you the YAML file of deployment. Okay, let me show you the YAML file of deployment. We'll go to the YAML file of deployment. We'll understand what is the difference between replica set and deployment YAML. So this is the deployment object, you see. This is also a high-level object which can be used for scaling, load balancing, and performing rolling updates. The main important feature we are having in the deployment object is like we can perform rolling updates. We can perform rolling updates. So what is this? We'll try to understand. Look at the YAML file. API version, kind, metadata, specification. All these things are common for each and every YAML file. So here also in deployment object, we're having 2 specification sections. One specification section you see for the Docker image. This is the Docker image I'm using. Nginx 1.7.9 is the Docker image we are using. And any container details, port number details we are mentioning in the last specification section. So if you go to the first specification section, try to understand. We are using, this is similar to our replica set only. We are specifying the replicas as 3. Selector, match labels is everything like similar to the replica set only. Okay, you don't need to compare anything. Everything is similar to the replica set. Your deployment YAML file is similar to the replica set only. See, you see the both specification sections. It is similar to the replica set only. The only difference is like whenever.
Hello.
Yeah, please.
కొద్దిగా పైకి వెళ్ళవా ఒకసారి. ఇక్కడ టెంప్లేట్ అని ఉంది కదా, అది ఎక్కడ యూస్ చేస్తాం?
So template is for this is the syntax. So this is how we need to provide for providing the metadata. So whenever you want to provide some metadata, you have to provide an option called template. Okay, this is for template. See what we are doing under the specification section. We have 3 important components. One is replicas. Okay, second one is selector. Other one is template. So under selector, we are having the child elements called match label as well as under selector, we have only one child element called match label.
Okay.
Under match labels, we have a child element called type.
Type.
Okay, template is one child element under specification. Under template, we have a child element called metadata.
Okay.
Under this template, we have two child elements. One is metadata, other one is specification. So this specification section, first specification section, if you observe, under the first specification section, we have a child element called template. So under this template element, we are having a child element called specification, metadata and specification. Got it now? Under this template field, we are having child elements called metadata and
Okay.
specification. So which one? This metadata. You're talking about metadata. Yeah. The metadata is only for the purpose only, user purpose only. Okay. With this metadata, we are not going to make any changes. Okay. So what we are doing, you see the first metadata. What is the use of this metadata? By looking at this metadata, we will understand that we are going to, this is the name we are providing for the deployment. What is the kind? What is the object kind we are using? Deployment. Object kind is deployment. What is the name of the deployment we are providing? Nginx -deployment. So what is the author name? Author name is OMC. Type proxy server. Okay, these are the details we are just giving to understand what is the name of the deployment, who is the author of this particular one. So author and type we are providing under labels.
Okay.
So under labels you can provide anything. Even if you do not provide this label section, no need to worry about it.
Okay.
Okay, this metadata section only for the purpose of understanding what is the name of the deployment and what is the name, who is the author of this file, and what is the proxy server type and all. To understand only these things, we are giving this. That's it.
Okay.
Any metadata section you see, but this selector is having some importance. I told you, right? The selector is having some importance. Based on this type, if any type of proxy server is running outside, it will also consider that one, and it will decrease the number of replicas that it is creating.
Yes,
If one proxy server is running outside, it will create only 2 replicas. That is the idea of this replica selector field. Okay.
Yes.
And wherever you go, the metadata section. This metadata section is for pod now. This is for deployment level. And we should also specify what is the pod level, what is the pod name. So if pod is created, we should also mention that what is the pod name, right?
Yes,
so what is the idea? When whatever the object it is, we are going to create the replicas of pods only, right? Similar pod, more replicas. Similar pod, more replicas. So we are going to create a deployment object, but inside what we can able to see, we can see the Nginx pods. How many Nginx pods we can see? 3 Nginx pods we can see. What is the name of the pod that will create? The pod will be created with a name called Nginx pod. So this is about the pod level. Okay. And when we come down, anyhow, to create a pod and all, you need an image. Without Docker image, you cannot create a pod. Yes, we are using an image called Nginx 1.7.9. By using this image, we are going to create Nginx pod.
Okay.
Then what is this container name? I told you, right? Here we are creating 3 pods. Whenever I am giving replicas as 3, we are going to create 3 pods will be created, right? Replicas are 3 doesn't mean that 3 pods will be created. One thing we need to be very clear. In a single pod, we can create any number of containers. That is also the advantage of Kubernetes. In a single pod, actually we are doing one container. We are creating only single container in a single pod.
Okay.
That's why we don't have the difference between pod and container. Sometimes what happens, we might create multiple containers in a pod. So that time you need to mention the name of the container.
Okay.
That time you need to mention the name of the container. That's why we are mentioning the name of the container. So we can create any number of containers inside the pod. Inside the pod, you remember, inside pod, what will be running? Container is running. What is the name of the container?
Nginx.
Pod name is, so image name is this one. Container name is this one. This container will be running inside Nginx pod. And how many pods will be creating? 3 pods. What is the name of the whole file? Nginx -deployment. So this is the meaning of the YAML file. Okay. So if I want to create this, so what is the main idea of this YAML file? This is similar to the replica set only. It is similar to the replica set only, but we can perform a rolling update. How can we perform rolling update? We see here. So once we create a deployment YAML file by using this command, kubectl create -f deployment.yaml, to check the deployment is created or not, we can give a command called kubectl get deployment. Okay. So kubectl get pods means it will give the list of pods, right? So even you see previously, we'll go back here. We can use a command called kubectl get rs. What do you mean by kubectl get rs? What do you mean by kubectl get rs? Replica set. Okay, how many replica sets we have created so far? So far we have created only one replica set. Okay, so let me try to delete this one. At least will maybe the cache is not getting updated. That is the issue. kubectl delete -f. What is the replica? What is the name of the replica set here? kubectl delete -f. The name of the replica set is Tomcat -rs. Is showing like does not exist. Okay, in this way, if you have created a replica set, you can get the replica set by using kubectl get rs. If you create a deployment object, you can get the deployments by using kubectl get deployment. See why? Because we are not in a project. We are not going to create only one replica set. We may create many replica sets. We may create many deployment objects. Okay, for that purpose, we are using this command kubectl get. Okay, so we can always perform scaling. We can perform scaling. We can perform scaling. So apart from the scaling, we can also perform rolling updates. What do you mean by this? You see we have a command here to perform the rolling updates. What we are doing here, rolling update in the sense, presently we are using some image. Consider presently we are using some image called, what is the image in the YAML file we are using? You might have seen that. What is the image name? 1.7.9. This is the current Nginx image we are using. Okay. What do you mean by rolling update? So we have to update this image with some other image. How can I update this? Either we have to go for making changes in the YAML file. Otherwise, by using some commands also, we can make the changes. So we are using 1.7.9 and we are going to update the image as 1.9.1. So what is the image we are going to image? We are going to update the image as 1.9.1. Previously it was using some other version. Now I am going to update the image version as Nginx 1.9.1. So for this, we are using a command kubectl -. Okay, kubectl -. record. So this particular command, this is the syntax we are using. Deployment.apps Nginx deployment. We are going to set the image of this one into another one. I am going to set the image of deployment.v1.apps Nginx deployment into this one. So I'm going to make the image name. I'm going to change the image name in the particular deployment called Nginx deployment. This is the command. From where you get the command, you can go to Kubernetes cheat sheet. So in Kubernetes documentation, you can find the image for rolling update, a command for rolling update. So that you can get the command. You can use this command and you can change the image. Okay. So in that way also we can change. We'll get a message like image is updated and all. Okay. So let me create this. So this is the advantage of this one. Rolling update means like, suppose if 3 replicas are there. If 3 replicas are there, all the 3 replicas will not be updated at a time. All the 3 replicas will not be updated at a time. Okay, first one by one. If 3 replicas are there, the first pod will get updated with the image name. And the remaining 2 pods will be there with the old image names. Slowly, one by one will get updated. And without any downtime, all the pods will get updated with the latest images. Okay, latest image. That is the idea of rolling updates. So I'm going to copy this vi space deployment.yaml. Sorry. I'm not saving. Why? Because the YAML file was not correctly copied. So if it is copied this like this, if you want to exit from the contents, you can use :Q, this exclamatory mark. Usually what we will give :WQ, right? We will use :WQ for saving the contents. If you want to exit without saving the contents, you can give :Q, exclamatory mark. Now you can go there. So I'm going insert button. See, now I'm going to copy this one. Copy this. I'm going to paste it. Okay. So escape, shift : WQ. Now how to run, you know, right? How to run an YAML file and all. We can run the YAML file by using kubectl create -f deployment.yaml. Kubectl create -f deployment.yaml. Kubectl create -f deployment.yaml. Deployment.apps is created. You can see by using a command called kubectl get deployment. Kubectl get deployment. There is one deployment. Okay. There is one deployment. Actually, we asked to create 3 replicas. Okay, and only two are available. We'll give a command called kubectl get pods. See, 2 got created. Actually, our requirement is 3. 2 got created and 1 is still creating. Okay. So this is because of the issue. This is because, like, see, actually what happens is whenever we ask 3 replicas, and what is the cluster size we have taken? Can you tell me what is the cluster size we have taken? So the cluster size, defaultly we have taken the cluster size actually was 3, but there were some memory issues. That's why I have selected only 2 nodes, and the cluster was created with the 2 nodes. Okay, you can see the cluster given. You can see the cluster. I will show you the cluster size. Otherwise, you can give a command called kubectl. If you want to see the list of nodes, how can we see that? Kubectl get nodes. So kubectl get nodes. Only 2 nodes were there. Okay, only 2 nodes were there. But whenever I give 3 replicas, what happens? How the Kubernetes will distribute the pods? Suppose whenever I give 3 pods, if I have only 2 nodes in the cluster, what it will do? It will create each and every pod in each and every node. Okay, one pod will be created in each and every node. And in any another system, in any another machine, it will create the remaining pod also. That means it will try to distribute equally. Okay, if I have 3 machines and I'm going to give the 3 replicas, how it will create? In each and every node, it will create a single pod. In each and every node, it will create a single pod. But I have only 2 machines, right? I'm asking to create 2 replicas. What it will do? In a single machine, it will create 2 replicas. In another machine, it will create 1. Okay, this is how it will create. And because of the memory issues and all, the pods are not getting updated and pods are not getting created. See, we have asked to create 3, but only 2 were created and 1 is in the pending state. Okay, this is because of some memory issues. You don't need to worry about it. But concept wise, okay, we are good according to the concept wise. So whenever we ask to create 3 replicas in 2 machines, okay, 2 machines will be created. If you want to see the detailed output, you can see kubectl. Okay, what is the command we use? Kubectl get nodes. Kubectl get nodes -o wide -o wide. What it will show? It will show you the wide output. It will show you the wide output. And here, what you can see, how many? Otherwise, you can also give a command called kubectl get pods -o. Kubectl get pods -o. You can able to see. Okay, you can able to see that which one is running, which one is in the pending state. See, whatever the pending state, whatever the things that are in the pending state, okay, whatever the things that are in the pending state, so they were not allocated with any machine. Only the pods were running, they were allocated to some machine, and the pods were running in some machine. Because of some memory issues in the, okay, because of some memory issues in the nodes, so they are not getting created, they were not getting allocated. Okay, that is the meaning. So that is how we need to understand here. Because of some memory issues, they were not getting created. Okay, see, whatever the machines that are running, we can able to see the machine name, in which machine it is running and all. Whatever the machines that, whatever the pods that are pending, okay, that is not allocated to any machine. Okay, if it is allocated to some machine, it has to be in the running state, but it is not in the running state. And even we have I have shown you, right, how to whenever we are updating something, it is not getting updated. Okay, so that is also because of some memory issues here. So you can try, you can try by taking 3 machines. Okay, if it is not getting 3 machines, you also try with the 2 machines. You can practice like this. Why? Because practicing Kubernetes is very costly thing. We are not allowed to practice this one. Okay, in Google Cloud we are allowed, but you don't go to AWS Cloud and don't create clusters. The bill will be enabled. Bill will be enabled. Okay, you have to pay. You have to pay the bill in thousands. Don't do it. Okay, don't go for that kind of things and all. Anyhow, if you want to see how they will use pods and all in YouTube, you have lots of videos. You can go through the YouTube and you can watch the videos how they are creating pods and all. Anyhow, what is our intention? With the help of Nginx deployment, we would like to show you. With the help of Nginx deployment, I would like to show you. So once after creating the pods by using deployment, we need to perform some rolling update. So we can use the same command for rolling update. You see, like I'm using the same one image was running already. So I'm copying the same this thing. I can go for rolling update by giving this command.
From where you have taken this?
From Google, you can go to the Google. So you can go for command for k8s command for rolling update. Okay, k8s command for rolling up. Most of the things you will get in Kubernetes documentation on kubernetes.io. Okay, k8s command for rolling updates. You can see there. Just go to the official website, kubernetes.io. Okay. There you can go for the rolling updates and all. You can search. You'll find all the commands. Okay. This is the official website. Go to the documentation and you can find. So whatever the concept you are searching for, rolling updates, right? You can go for rolling updates. Can you able to see the command? kubectl set image deployments. Okay. You can take this image and you can apply. Okay, whatever the image you want to update, you can update. You can just come down. You can see the images like kubectl set image deployments to some other image. Okay. You can get the commands from here. Now you see we got an output called image is updated. Where it is. Can you able to see only 2 pods were created, right? Because of some memory issues. Only actually our requirement is 3. Only 2 were created, and both the deployments, both the pods were updated with the images. Images got updated. Previously we were using some image 1.7 point something. Now we have updated the image with 1.9.1. It is showing clearly. It is showing the image. The output as image updated. Okay. So this is what we can do with the deployment.aml. So we are using deployment.aml. It is similar to our replica set only, but if you want to perform some rolling updates, you can go for deployment.aml. Okay, that is the advantage we are having. So rolling update is nothing but only updating the image. So the image will be updated slowly, one by one. Okay, So first it will get updated to one pod. So the remaining pod will be providing services to the users. Once the first pod is successfully updated with the image, then only the second pod will get updated with the image. That is how it plays. Okay, thank you. That's it for today. We'll discuss tomorrow. We'll continue tomorrow.
స్మాల్ డౌట్ నుంచి గూగుల్ క్లౌడ్ అంటే కన్సోల్ అవ్వట్లేదు.
Console in the sense, maybe you are not using a correct card. Your card must be enabled for international transaction. Yesterday also, Salma, are you there?
Yes.
Salma, how about you? Got created your account?
No, sir. Still getting. I'm not able to create account.
What error you are getting? Maybe sir,
while doing the payment, like I've tried 2-3 different type cards, but it's not accepting.
Yes, it is not accepting. Have you verified whether your card is enabled for international transactions? That is the important thing.
While creating AWS account, I tried with the same card now also.
Okay.
That on that time it accepted.
Yeah, maybe that is accepted for AWS. Please make sure that whatever the card you are using for this, okay, and if one card is not working out, please try with another card. That is the issue here. Payment most of the
Same
times
thing had done.
most of the times you will get issues with the payment only. Okay, so you will provide card details and all, but it is showing some error like unable to proceed with this and all. Okay, like that some issues will be there. So please try with some other cards. What I have done is, even I have also tried. Maybe if they are not, we need to check whether they are providing the free trial for this Kubernetes and all. Maybe you try with some other cards and make sure that international transactions is enabled. International transactions enable చేసిన తర్వాత ఒకసారి ట్రై చేయండి. ఒకవేళ కానీ వర్క్ అవ్వకపోతే వేరే కార్డ్ యూస్ చేయండి.
అది ఎలా చెక్ చేయొచ్చు సార్ ఇంటర్నేషనల్ ట్రాన్సాక్షన్?
అది మీకు ఇంటర్నెట్ మీ పర్సనల్ అది ఇంటర్నెట్ బ్యాంకింగ్ అని ఉంటే ఆప్షన్ ఉంటే ఒక్కొక్క నెట్ బ్యాంకింగ్ కి ఒక్కలా ఉంటుంది అనమాట. ఇప్పుడు HDFCకి ఒక ఆప్షన్ ఒకలాగా ఉంటుంది ఆప్షన్. లోపలికి వెళ్తే మన సెట్టింగ్స్ లోకి వెళ్ళి మీరు ఇంటర్నేషనల్ మీరు చూడొచ్చు అనమాట. అది మీరు గూగుల్ అయినా సెర్చ్ చేసి చూడొచ్చు. హౌ కెన్ ఐ ఫైండ్ దట్?
3 కార్డ్స్ యూస్ చేశాను అయినా రాలేదు నాకు.
3 కార్డ్స్ యూస్ చేసినా కానీ అవ్వట్లేదు. అకౌంట్ క్రియేట్ అవ్వట్లేదా?
అకౌంట్ క్రియేట్ అవ్వట్లేదు. అంటే నాది HDFC ఇంటర్నేషనల్ బ్యాంకింగ్.
ఓకే,
అంటే నేను ట్రై చేశాను.
వాట్ ఎర్రర్ ఇట్ ఇస్ షోయింగ్? ఏం ఎర్రర్ చూపిస్తుంది?
unable to connect I mean invalid card details అని వస్తుంది ఒకసారి.
ఇన్వాలిడ్ కార్డ్ డీటెయిల్స్ మామూలుగా కరెక్ట్ కార్డ్ డీటెయిల్స్ ఇచ్చినప్పుడు ఇన్వాలిడ్ కార్డ్ డీటెయిల్స్ అని అయితే రాదు. ఒకసారి కార్డ్
అండ్ unable
నాకు కూడా సేమ్ ఎర్రర్ సార్. నేను కూడా 2-3 టైప్స్ ఆఫ్ కార్డ్స్ యూస్ చేశాను, సేమ్ ఎర్రర్ వస్తుంది.
యాక్చువల్గా నేను ఇంతకుముందు ఫ్రీ అకౌంటే చేసేవాడిని. తర్వాత ఏమైందంటే ఇది ఫ్రీ అకౌంట్ సపోర్ట్ చేయట్లేదు అనమాట. ఫ్రీ అకౌంట్ సపోర్ట్ చేయట్లేదని నేను ఆ కార్డ్ డీటెయిల్స్ ఇచ్చి బిల్లింగ్ ఎనేబుల్ చేశాను. బిల్లింగ్ ఎనేబుల్ చేసిన తర్వాత వర్క్ అవుతుంది ఇది. ఏం చేద్దాం, ఒక్కసారి మీరు యూట్యూబ్ లో చూస్తారా? ఒకసారి యూట్యూబ్ లో మీకు వచ్చిన ఎర్రర్ ని యూట్యూబ్ లో ఒకసారి ట్రై చేసి చూడండి. ఒకసారి ఖచ్చితంగా అయితే క్రియేట్ అవ్వాలి. మరి ఎందుకు ఈ మధ్య ఏమైనా రెస్ట్రిక్షన్స్ ఏమైనా ఉన్నాయో లేదు, నేను ఒకసారి చూస్తాను, చెప్తాను అసలు ఎందుకు క్రియేట్ అవ్వాలి.
ఓకే.
సో మీకు వచ్చిన ఎర్రర్ ఏదైతే ఉందో దాన్ని అట్లాగే యూట్యూబ్ లో సెర్చ్ చేయండి. ఎవరో ఒకరు చెప్పుంటారు అనమాట ఈ ఎర్రర్ వస్తే మనం ఎట్లా దాన్ని సాల్వ్ చేయాలని. అంటే కార్డ్ సైడ్ ఇష్యూవా లేకపోతే అసలు యాక్సెప్ట్ చేయట్లేదా, ఫ్రీ బిల్లింగ్ ఎనేబుల్ అవ్వకుండా అసలు మనం యాక్సెప్ట్ చేయట్లేదా అనేది మనకు అర్థం కావట్లేదు.
ఓటీపీ కూడా జనరేట్ అవుతుంది.
ఓటీపీ జనరేట్ అవుతుంది, ఓటీపీ ఇస్తున్నాం, అయినా కానీ తర్వాత లాస్ట్ లో అది ఆ కార్డ్ తో మనం వర్క్ చేయలేమని చూపిస్తుంది. అది నేను చూసాను, నేను కూడా చూసాను. మనం చెక్ చేయాల్సింది ఏంటంటే ప్రెసెంట్ ఆ ఫ్రీ టైర్ ఎలిజిబిలిటీ అనేది. అంటే ఇప్పుడు మన కార్డ్ తో మనకు ఒక ఆప్షన్ ఉంది ఇక్కడ, ఎనేబుల్ బిల్లింగ్ అని అడుగుతుంది. మనం ఏదైనా సర్వీస్ యూస్ చేయాలని చూస్తే కాకపోతే ఇక్కడికి వెళ్ళి క్యూబర్నెటీస్ ఇంజిన్ క్లిక్ చేస్తే నేను బిల్లింగ్ ఎనేబుల్ చేశాను కాబట్టి ఇప్పుడు ఏం అడుగుతుంది, అది క్లస్టర్ క్రియేట్ చేసుకుంటారా అని అడుగుతుంది. యూ వాంట్ టు క్రియేట్ క్లస్టర్ అని అడుగుతుంది అనమాట. సో ఐఎమ్ క్లికింగ్ ఆన్ దిస్.
క్రియేట్ క్లస్టర్ ఆప్షన్ కూడా చూపించట్లేదు సార్.
అవును సల్మా, యాక్చువల్ గా నాకు ఎలా చూపిస్తుంది అంటే ఇక్కడికి వెళ్ళిన తర్వాత క్యూబర్నెటీస్ ఇంజిన్ లోకి వెళ్తే ఇక్కడ క్లస్టర్స్ అని ఉన్నాయి కదా, క్లస్టర్ లోకి వెళ్ళండి. ఆల్రెడీ ఇప్పుడు ఎక్కడున్నా నేను క్లస్టర్ లోనే ఉన్నా. ఓకే, క్లస్టర్స్ లోనే ఉన్నా. సో క్లస్టర్ ఆల్రెడీ సెలెక్ట్ చేస్తున్నాను కాబట్టి మనకు చూపించాలి. ఇక్కడ క్రియేట్ ఆప్షన్ ఉంటుంది క్లస్టర్స్ లో.
సార్ ఇలా ఆప్షన్ చూపించలేదు సార్ క్రియేట్ అని.
అదే ప్రాబ్లం ఏంటంటే మీరు బిల్లింగ్ ఎనేబుల్ చేయలేదు కాబట్టి చూపించట్లేదేమో అంటున్నా. అంటే ఫ్రీ టైర్ ని సపోర్ట్ చేయట్లేదేమో అంటున్నా క్యూబర్నెటీస్. మీరు వేరే ఏదైనా అసలు వేరే సర్వీస్ ఏదైనా యూజ్ చేయండి. ఇప్పుడు మీరు ఇక్కడికి వెళ్తే మనకి ఫ్రీ టైర్ సర్వీసెస్ సమస్య అదే, క్యూబర్నెటీస్ తో వచ్చిన సమస్య అదే, మనం ప్రాక్టీస్ చేయడానికి ఉండదు. ఫ్రీ టైర్ సర్వీసెస్ ఇన్ గూగుల్ క్లౌడ్ అని అంటే గూగుల్ క్లౌడ్ లో ఏ సర్వీసెస్ ని ఫ్రీ టైర్ కింద యూజ్ చేయొచ్చో మనం చూసుకోవచ్చు. ఇక్కడ ఫ్రీ టైర్ సర్వీసెస్ ఇన్ ద గూగుల్ క్లౌడ్ అని ఇస్తే. సో ఫస్ట్ మనకి యాక్చువల్ గా $300 ఫ్రీ క్రెడిట్ ఇస్తాడన్నమాట అకౌంట్ క్రియేట్ చేసేటప్పుడు. ఓకేనా, మన అకౌంట్ సక్సెస్ఫుల్ గా క్రియేట్ అయిన తర్వాత $300 ఫ్రీ క్రెడిట్ ఇస్తాడు. అది ఇప్పుడు ఇస్తున్నాడా లేదా అర్థం అవట్లేదు. ఇక్కడ ఏదో ఇచ్చినాడు చూడండి 24/7 ఫోన్ సపోర్ట్ అని. అట్లా ఏదన్నా చేసినా కానీ మనకు అర్థం అవుతుంది విషయం. సర్వీసెస్ ఫర్ ఫ్రీ టైర్.
అజూర్ క్లౌడ్ అయినా అట్లానే ఉంటుంది.
ఆల్ కస్టమర్స్ అజూర్ క్లౌడ్ కూడా అంతే. మనకంటే క్యూబర్నెటీస్ యూజ్ చేయడానికి రెస్ట్రిక్షన్ ఉంటుంది అనుకుంటా. మీకు ఒకవేళ అజూర్ అకౌంట్ ఉంటే ఒకసారి ట్రై చేసి చూడండి అజూర్ క్యూబర్నెటీస్ క్లస్టర్. ఇక్కడ ఆల్ కస్టమర్స్ కెన్ యూజ్ 25+ ప్రోడక్ట్స్ ఫర్ ఫ్రీ అన్నాడు. దాని మీద క్లిక్ చేస్తే మనకు వచ్చిన క్రెడిట్స్ లో, అంటే మనకు ఫ్రీ క్రెడిట్స్ ఇస్తారని చెప్పాం కదా, ఆ ఫ్రీ టైర్ కింద మనం ఏమేమి వాడచ్చు అనేది ఇక్కడ చెప్తున్నాడు. ఇవి యూజ్ చేయొచ్చు అంట. యాప్ ఇంజిన్, క్లౌడ్ ఫంక్షన్స్, ఎక్కడ కూడా మనకు కావాల్సిన ఏం లేదు. క్యూబర్నెటీస్ ఉందా, కంప్యూట్ ఇంజిన్, ఈ మెషిన్స్ యూజ్ చేయొచ్చు. ఏ కంప్యూటర్ ఇంజిన్ అంటే ఏంటంటే మనకి AWS లో EC2 అంటాం కదా, AWS లో EC2 మెషిన్స్ ఉన్నాయి కదా, సేమ్ ఇక్కడ కూడా గూగుల్ క్లౌడ్ లో మనకి కంప్యూట్ ఇంజిన్ అంటాం. సపోజ్ మనం ఏదైనా సర్వర్ క్రియేట్ చేయాలంటే కంప్యూటర్ ఇంజిన్ అనే ఆప్షన్కి వెళ్ళి సర్వర్స్ క్రియేట్ చేస్తాం. ఓకే, ఇది కూడా ఫ్రీ టైర్ కింద ఇచ్చున్నాడు. ఫ్రీ టైర్ కింద యూజ్ చేయొచ్చు, కాకపోతే లిమిట్ ఉంటుంది అనమాట. ఓన్లీ ఫ్రీ టైర్ ఎలిజిబిలిటీ ఉన్న రీజన్స్ లో, కొన్ని రీజన్స్ లో ఉన్న సర్వర్స్ మాత్రమే మనం క్రియేట్ చేసి యూజ్ చేయొచ్చు. అది కూడా ఓన్లీ E2 మైక్రో అని మాత్రమే మనం యూజ్ చేయొచ్చు అని. ఎట్లా మనం ఎత్తుక్కోవచ్చు అనమాట ఈ ఫ్రీ ట్రయల్ కి. ఇది కూడా ఇచ్చినారు చూడండి. గూగుల్ క్యూబర్నెటీస్ ఇంజిన్, నో క్లస్టర్ మేనేజ్మెంట్ ఫీ ఫర్ 1 ఆటో పైలట్ ఆర్ జోనల్ క్లస్టర్ ఫర్ బిల్డింగ్ అకౌంట్. నో క్లస్టర్ మేనేజ్మెంట్ ఫీ, ఏం లేదు. ఆటో పైలట్ అకౌంట్ కి అసలు బిల్డింగ్ ఏం పడదని చెప్తున్నాడు. ఫర్ క్లస్టర్స్ క్రియేటెడ్ ఇన్ ద ఆటో పైలట్ మోడ్, పాడ్స్ ఆర్ బిల్డ్ ఫర్ ద సెకండ్ ఫర్ create in the standard mode. Each user node is charged standard compute engine price. So no cluster management fee for 1 autopilot. ఓకేనా, ఒక ఆటో పైలట్ కానీ ఒక జోనర్ క్లస్టర్ కానీ క్రియేట్ చేసుకుంటే బిల్లింగ్ ఏం పడదని చూపిస్తున్నాడు. అసలు ముందు మనకు అకౌంట్ క్రియేట్ అయితే కదా, అది కదా సమస్య. అకౌంట్ క్రియేట్ అవ్వట్లేదు. మాక్సిమం ఇష్యూ అదే ఇక్కడ క్యూబర్నెటీస్ ప్రాక్టీస్ కి ఏంటంటే మనకి ఓన్లీ ఫ్రీ టైర్ ఏదైనా సపోర్ట్ చేస్తే చేయాలి, లేదంటే మోస్ట్లీ మనకి ఇంకా. ఇక్కడ ఎక్కడ క్యూబర్నెటీస్ ని ప్రాక్టీస్ చేయడానికి కొన్ని ప్లాట్ఫామ్స్ ఉన్నాయి మీకు. ఇప్పుడు డాకర్ ఇన్స్టాల్ చేసుకున్నా సరే, డాకర్ లో మనకి క్యూబర్నెటీస్ అనే ఒకటి ఉంటుంది అనమాట. క్యూబర్నెటీస్ అని ఒకసారి మీకు చూపిస్తాను, నెక్స్ట్ క్లాస్ లో మీకు చూపిస్తాను. ఇంకా ఫ్రీ టైర్ సోర్సెస్ ఏమైనా ఉన్నాయో, ఒకవేళ గూగుల్ క్లౌడ్ కాకపోతే మనం ఎక్కడెక్కడ క్యూబర్నెటీస్ ప్రాక్టీస్ చేయొచ్చు చూపిస్తాను. ఓకే,
థ్యాంక్ యూ.
Okay, thank you. Try creating an account, okay, with some other cards and all. Otherwise, you please search with that error. ఆ ఎర్రర్ ఎందుకు వస్తుందో ఒకసారి మనం చూద్దాం. ఒకవేళ అకౌంట్ క్రియేట్ అవ్వకపోయినా వేరే సోర్సెస్ ఏ ఉన్నాయి క్యూబర్నెటీస్ ప్రాక్టీస్ చేయడానికి చూపిస్తాం.
ఓకే,
ఓకే దెన్, థ్యాంక్ యూ. విల్ మీట్ టుమారో.